This is the Unit 7 answer key for questions number 23 through 27 on the study guide. For these, they are mostly about the scientists that we studied and how they figured out what was in the parts of the atom. I am going to, on purpose, give a really kind of brief overview, but you should know that on the test and the expectations for the CLR is you need to know the order. So I'm going to make a quick list. You're going to need to know the order, which I'm about to go over here in just a second. You need to know any technology that was used. So, for example, the cathode ray tube and other things that scientists knew about in order to do their research. Some famous experiments, which I will mention. Famous experiments. And finally, you're going to need to know any models and who they're associated with, and that'll also go over here too. So again, I'm not going to hit on every detail that you're going to need to know. You should, if you are confused about any of the people in this order, you should definitely go back to that Google Doc that I emailed to you and is also in the Google folder. And I've got videos for every single one of these that goes into much better detail. So the first thing that we're going to talk about is order, and I'm going to kind of go through all those first. So the first person on the list is Democritus. He was the one who lived in a few thousand years ago. Then we've got Dalton. He is much more recent, but still pretty far back. The next one is Thomson. No P. Thomson. Number 4 is going to be Rutherford. Number 5 is debatable. Some people put him in a different place. So 5 can kind of float in a couple of different places, but I think that he belongs here. You could easily argue that Chadwick belongs in a different spot. And if you do want to argue that on the test, your answer is dependent upon your argument, not your order or memorizing anything. The next to last is Bohr. And then finally, wave model. And the wave model is what we consider to be the most current, or the one that we're currently using as the description of the atom. So now a real brief description section. Again, I'm not going to go into super big detail. So Democritus was the first one to get the idea of the atom. And the story kind of goes that he was walking along the beach, saw some rocks that were crumbling into pebbles, and wondered, well, I wonder how far something can be broken down. And he decided, he didn't use any technology or anything, he just decided that there has to be something that's small and indivisible, and he named it atomos. That was what the word meant. But he had really no idea what it looked like. He imagined these little shapes with like hooks or barbs sticking out of them because he knew that they stuck together somehow. But he thought that maybe there were circle ones and like triangle ones and like maybe some square ones, but that was pretty much the extent of where his mind was at. But he was the first one to think of this idea that there's this indivisible amount of substance. The next person to come along was Dalton, and he used the law of ratios. So he was the first one to actually use any science, and what he did was he took water, which water has H2O, right? So there's the oxygen and hydrogen, and water kind of makes this molecule that is a V shape, kind of like this. And what he did was he broke it down. He actually used an electric current to get oxygen by itself and 2 hydrogens by themselves. This may not seem like that big of a deal, but what he showed was that when you break apart water, and it doesn't matter if you start with a gallon or like a thimbleful, but when you break it apart, you're always going to get the same ratio of 1 part oxygen to 2 parts hydrogen. And on top of that, when you reassemble it, like when you force the hydrogens and the oxygens to rebond, you're going to get the exact same amount of H2O that you started with. So before this, people were even thinking that maybe there is like a water atom, when people also thought that you could destroy matter. So like when you burn things, people thought that they were ultimately destroyed. He did have kind of a model, but it's not one that we use very much in this class, but for the sake of filling in this box, he kind of like assigned labels. So like he thought that maybe oxygen should be like this symbol. I don't even know if that's right or not, but he just made up symbols. And then like maybe hydrogen had like this symbol, and like he had these different symbols for each of the elements, and he didn't know of that many. But his idea was that everything on the planet, everything in the universe, was made of just this really short list of elements, whereas Democritus thought that there was like an element for cheese and an element for rock and an element for flesh, stuff like that. So Thomson was this guy that decided that, or he figured out using a cathode ray tube, so that's the type of technology. And for a description of what that is, you should go watch the video. But basically, it's a big glass tube that's got all the matter sucked out of it, with the exception of a particular element, and it sends high voltage through. And he figured out that by holding a magnet up to it, it would either be attracted or repelled, depending on which side. So he was the one that figured out that there's a plus and minus characteristic to the atom. His model of the atom was something that was used, and he called it the plum pudding model, which was such a British thing. It's unbelievable, because nobody here eats plum pudding. What the heck is that? I would have called it the chocolate chip cookie model. So he imagined like this cookie material. It wasn't actually cookie, but like this material that the atom was made out of, and all that material on the inside was like positively charged. And I don't know if this is true, but I think his idea was that the amount of positive stuff determined how strongly it was attracted or repelled. And then inside of it, he imagined these little separate portions, like the chocolate chips on the cookie, and those separate portions were the minuses. We now know that this was way off, but he was the first person to figure out that there was pluses and minuses using a pretty simple yet scary looking technology at the time. You should go watch the video. That brings us to Rutherford. He figured out that there was such a thing as a nucleus. So what he did was he did something called the gold foil experiment. Again, you should go watch the video to get some details about how this worked. But basically what he did is he determined, can't think and talk. He determined that this cookie idea, or the plum pudding model, was not possibly true. He figured out that most of the atom was empty space. So atom equals empty space. And he figured out that the very center was really positively charged. So he was the one that said, all right, there must be this center that has all the plus part, and then buzzing around it, and he had no idea how or why, but buzzing around it were all the electrons. And this is maybe the symbol of the atom that you've probably most recognizable. After that, or somewhere in the midst of Bohr and Rutherford, and even wave model, arguably, Chadwick was doing his experiments using radiation. Chadwick figured out neutrons. Again, he had an experiment that I don't know the name for, but again, it's in the video. He had an ingenious experiment where he basically shot radiation through a material and proved that it was knocking loose this non-plus, non-minus material, and he didn't know what they were like or where they came from, but he knew that it had mass and no charge, and he called them neutrons. There were a bunch of people who did more experiments later that actually ended up leading us to atomic bombs and atomic energy, but that was his contribution. He did not have a model. He just figured out the neutron. Bohr, as you already well know, figured out that electrons have energy levels. So Bohr thought that this meant that electrons had like these exact locations that they were in, and as you already know, we've drawn a whole bunch of these. He saw them as these concentric rings around the nucleus. He determined that electrons have energy that relates to these levels based on light that would come out of them, and he did experiments, again using radiation, and he would measure the type of light that would come out, and he called these quantum states. And that means that basically an electron can't be somewhere in the middle of two rings. It has to be on one of these two rings. Where he was wrong leads us to the wave model. The wave model took Bohr's diagram, and they said electrons are like waves and particles at once. And that may not sound like that big of a deal, but basically what they figured out was that electrons, because they behave so strangely, there's still a nucleus, just like Bohr and even Rutherford before him knew, but these layers that Bohr thought existed are not quite accurate. It's actually like more of this like dense cloud of probability. So what that basically means is they could show using math, they didn't use a technology, they used a lot of math, that an electron has a 90% probability of being, that's a 90% probability region, and then like the next layer, what Bohr thought was like another ring on the outside, actually like had more of this like dumbbell shape or a figure 8 shape maybe, that came out in 3 different 3D directions, and it like started getting super crazy complicated. If you want to see something to kind of give you an idea, Google search SPDF orbitals, and it'll show you what they picture these regions looking like. But it all came down to using a whole bunch of math and physics to figure that out. So going quickly to get through the rest of these, which model came first? Plum pudding came before Bohr. Bohr model came before the wave. In class, we drew drawings of atoms and ions. Which of the models have we been using to draw atoms? We have been using Bohr mostly, and it's not part of the question, but also a little bit of Lewis. And these are imperfect because it's so hard to draw a wave model drawing. But if you pursue chemistry in college, you will definitely be using those more frequently even than Bohr.